right. Hey, everybody, Mr. Fortin here. We're going to get into it right now, section 6.5, with the definition of tangent ratio. Now, I know we've had our fun here the last few classes doing our Desmos tasks and sort of easing our way into trigonometry. And we've noticed we've spent a lot of times with ratios. We're going to get the names to a few of these ratios in the upcoming classes. We've looked at slope angles and how slope angles created a slope ratio. And then on Friday, we talked about how that ratio, right, with any reference angle in a right triangle, there would be a unique opposite over adjacent ratio for that reference angle. And now we're just learning, the only thing changing today is that we're going to learn the official vocabulary word for that, and that is going to be the tangent ratio. So take a second, put this in your notes, try to digest this real quick here and realize, hey, this is going to be very similar to what I've been telling you and what you've been practicing the past few days here. But here we have the definition of tangent ratio. When an angle is in a right triangle, or if it's not in a right triangle, let's just say we have an angle, that angle is going to have a tangent ratio. The tangent ratio of that angle is the ratio of its opposite side length to its adjacent legs side length. And that's what the tangent ratio is. Tangent is opposite. Tangent of an angle is its opposite over adjacent ratio. Right? 2 means it's a ratio, and 2 would mean this over that, right? Opposite over adjacent. So that's what we're going to practice over these next few days here. So let's just get this down here because we've actually already seen this. We've seen this with a lot of these angles here. Remember the 11-degree angle? We were dealing with the 11-degree angle quite a bit on Wednesday's lesson. Thursday and Friday's lessons, the 18-degree angle, right? The kite was tethered at an 18-degree angle of elevation from the ground. 22-degree angle, that one came up actually in the equation y equals 2/5 x, which was on Wednesday's assignment. And finally, tangent of 45 degrees. Well, 45-degree angle, we found the opposite over adjacent ratio also in Wednesday's assignment here. So one thing to point out here, the tangent ratio, an important thing to get at here, and we're definitely be dealing with these tangent ratios quite a bit over the next few days here, because every acute angle has a unique tangent ratio. I might want to write that one down too, a unique tangent ratio. And you should have seen this last class, right? You should have seen this last class and the class before that, that if I had an 11-degree angle, I knew that that was going to create a 1:5 opposite over adjacent ratio, right? Opposite over adjacent ratio. And then if that 11-degree angle changed, right, that 11-degree reference angle changed to a different degree measurement, there's actually no way, right? No way that we could have a 1/5 opposite over adjacent ratio, okay? Because if you had a right triangle with a 1/5 opposite over adjacent ratio and with the right angle in the middle here, it would have to be similar to that 11-degree angle here, okay? To that triangle with the 11-degree angle. And it couldn't be similar if it was a different angle. Anyways, we talked about that on Friday, but let's get into it right now because, hey, we've already seen a few of these here. Let's start thinking about them, right? Start thinking about why we know it's true here. That tangent of 11-degree angle is approximately 0.2. Do you remember that? Do you remember that from Friday's class? Remember that from Wednesday's class? Kind of came up in both of them here. But just to point out to you the tangent, any angle, okay? So let's start by drawing maybe an 11-degree angle down here as kind of our example, maybe put in your notes here. Definitely have this written down by now. Hopefully pause the video and write the definition. I definitely want you to write the definition down. I think it'll help you. But anyways, I want to start this here by tangent of 11 degrees, just show you how this works within a right triangle. I'll go through all of these examples as a matter of fact here. But an 11-degree angle, well, we got to start with an 11-degree angle. I'm going to eyeball it. That's pretty darn acute. So let's eyeball it real quick here. Approximately 11 degrees, right? Really small. Is it 10 degrees? Is it 9 degrees? Is it 15 degrees? I can't really tell here. So we'll say that this is an 11-degree angle. Okay, this is where our reference angle is going to be 11 degrees here. This 11 degrees angle, the angle's right here. Look, there's a side of the angle here, another side of the angle here. Oop, we may have a right triangle, right? It's an 11-degree angle, an acute angle, and a right triangle. It has an opposite over adjacent ratio that's equal to about 0.2. We saw that on Friday's class for sure, and Wednesday's class as well. So this here, right, say if this length here, if the adjacent, okay, this is adjacent. Let's say our adjacent here equaled 1, then our opposite would have to equal about 0.2, right, 0.2, okay? So do you remember that, right? 11-degree angle always had a 1:5 ratio, 1:5 ratio, and 1:5 written as a decimal, right? If I have a calculator here, we'll definitely use calculators here today. If I do 1 divided by 5, I get 0.2. I get 0.2 as my decimal here, okay? So as we saw, right, anytime we have an 11-degree angle in a right triangle, it's going to be a similar triangle to that, and it would have that same tangent ratio, same tangent ratio. So if I were to extend this a little bit further, a lot further, let's pretend we got 1, 2, 3, 4, 5, right? Let's pretend we have a 5 adjacent leg, right? Adjacent here. Remember, if I do an 11-degree angle here, and here, this opposite side, okay, this is the opposite side. So remember, reference angle here is 11 degrees. Right? I'm trying to draw a similar triangle to this here, 11-degree angle here. This is just kind of eyeballing it for demonstration purposes. If this were 5, remember, this had to be 1, right? It had to be 1 from what we saw the other day here. Approximately a 0.2 to 1 ratio, or a 1 to 5 ratio. And what we're going to see in a second, right? Look here, I actually included the approximate symbol there because you know what? These trigonometric ratios, the tangent ratio isn't going to be exactly 0.2 for an 11-degree angle because that's just a little bit too convenient. Math doesn't always want to be that convenient for us. So tangent ratios are proven, right? Are set up through some fancy math. But for ours, it appeared it was 1/5. It's approximately that. It's approximately 0.2. But we'll get to the exact answer on the coming slides here. Okay, we also looked at a tangent of 18 degrees. Yeah, that's right, we did. First, we called it, what was the slope angle going on here for, well, slope angle was an 18-degree angle. So this was actually the situation where we had the kite, right? Remember we had the kite here, and 18-degree angle is a little bit bigger. So maybe I should make this angle look a little bit bigger. Okay, something like this. Okay, remember we had the kite and we had the person who was 5 feet tall, and this was 1, 2, 3, right? 15. This was 3 times larger. Remember, this person who was 5 feet tall stood 15 feet away from where the kite was tethered at an 18-degree angle. Okay, so here we have a right triangle, a reference angle of 18 degrees. Remember, with the 18-degree angle, it was always in a 1 to 3 slope ratio, as we called it. But what we're going to call it now is we're going to call it the tangent ratio. So tangent of 18 degrees equals approximately 1/3. So that ratio, that relationship is going to be true for any right triangle that has an 18-degree angle. So we're definitely going to use this to solve some problems here, to fill out some unknowns. So for instance, if I had a 1-unit adjacent side, so just reminders here, reminders on vocabulary that we have here. This is the angle here, 18-degree angle. This is your hypotenuse, right? This is your hypotenuse. And then you have 2 legs that are related to this 18-degree angle. First, you have the opposite, right? This is our opposite side, right? Would be 5 here because it's opposite. It doesn't, neither side of the 18-degree angle is that side over there. It just intersects these 2 sides of this angle, intersects the 5 side. And then this is our adjacent leg here because it's part of that 18-degree angle, right? It's not the hypotenuse, but it's the other one. It's the other side is part of the 18-degree angle here. So 5/15, that's approximately 1/3, right? Well, 5/15 is 1/3, but tangent of 18 degrees is approximate. We're going to see in the next slide. Or next coming slides. It's pretty close to 1/3 here. Okay. So if I have a 18, let me do the 18-degree angle again here. I'm trying to make a straight line here, or best I could do. Okay. So approximately the same as I had earlier. Okay, right, 18 degrees. Let's pretend that this is 18 degrees. I'm not doing it perfectly. Well, this looks like this is about 1/3 as long as this 1-unit side that we have down here. Okay, so opposite over adjacent. Okay, if my adjacent here is 1, then this is going to have to be about 0.333 repeating, right? Repeating here. Okay, which actually is, right? 1/3 is exactly 0.333 repeating, right? Repeatings we have here, okay? So I don't really need that repeating symbol here because tangent of 18 degrees isn't exactly 1/3. It's pretty close to 1/3 as we see here. But anyway, just to show you here, right? So what this tells us, tangent of 18 degrees, is that if we have a 1-unit adjacent leg of a right triangle, then this actually here would be the tangent, right? The value of the tangent here, tangent of 18 degrees. Opposite over adjacent is in a 1 to 3 ratio. Continuing onward here, this was one we didn't really do tangent of 22 too much, but in Wednesday's class, they asked you to graph this out and try to figure out what the slope ratio was, okay? Slope ratio. So y equals 2/5 x. Well, 2/5 x was rise 2, okay? Run 1, 2, so 2, let's go 1, 2. Okay, so this is like 1, 2, and then 3 or so, 4, 5. That looks about right. That's a little bit larger than the 18-degree angle that I had a bit earlier here. So a 22-degree angle results in a 2 to 5 ratio, right? A 2 to 5 ratio here. So tangent of 22 degrees is 2/5, or what you're going to see is all of our tangent ratios are going to be written out as decimals. So get used to it as decimals right here, okay? So if I have a 22-degree angle, right, a little bit bigger than these 18-degree angles, just a tad, right, just a tad bigger here. But if I have a 22-degree angle, okay, 22-degree angle, and yeah, it's a little bit, yeah, maybe about 22 degrees, I'm not sure. But let's say that this is 1 right here, then this is gonna be 40%, right? 40% the length of the adjacent side. Opposite over adjacent is in a 0.4 to 1 ratio, right? Or a 2 to 5 ratio if you wanted to get a more precise fraction for us here. Tangent of 45 degrees, what about that one? Actually, that was kind of an interesting one. I think this one we should actually maybe kind of draw out here. This one here came out in Wednesday's class when you had to graph y equals x plus 4. Okay, so slope of that was 1. Okay, slope of this was 2, 5, and that's the tangent ratio there, right? Slope of this is 1. So tangent of 45 is actually 1, right? Actually 1. We saw that one on Wednesday's class. But anyways, just to check it out here, I might just sketch a 45-degree angle, right? So it's about twice as large as this 22-degree angle, but it's half of a right angle here. So let me just kind of eyeball it out. That's about 45 degrees. And check it out. What do we notice here? Well, if we have a 45-degree, okay, 45-degree acute angle in a right triangle, it's an isosceles right triangle, right? It's an isosceles right triangle here. So here, notice here, I put an equal sign here, not an approximate symbol. I put an equal sign right here because tangent of 45 degrees does have an exact answer that you can get in your calculators. You can get in a trig table, which will be in your textbook. We'll go over that in a second. And here, right, if we have this is our theta. This is our reference angle. And it doesn't matter if this is the reference angle, but ref angle here. It doesn't matter if this is the reference angle or not. If that's the reference angle here, this would be in a 1-to-1 ratio, okay, or an x to x ratio, and that's just going to equal 1, right? Anything over itself is 1, okay? So 45-degree angle, right? If we have a 45-degree angle and in a right triangle, and we know opposite it is going to be a side length of 3, okay? Adjacent to it's also going to be a side length of 3. I mean, we know it's a freaking isosceles right triangle if we have a right angle and a 45-degree angle right there. But now we can actually use tangent, right? Because the tangent of 45 degrees, we'll see in a calculator, we'll put it in there, is equal to 1. And if the opposite side is 3, that means that the adjacent side also has to be 3, okay? So we're going to have to practice solving equations involving this coming up pretty soon. We'll get to that today in today's lesson. But one question you guys might have here, a little bit overwhelmed, right? Math's about getting overwhelmed, getting a little bit out of your comfort zone, but then figuring out strategies to get what you need to get out of it here. So a very good question you might be having right now, being like, I'm anticipating I might be kind of overwhelmed by this. Because last slide, checking it out here, how many angles did I just go over with you guys there? Well, tangent of 11 degrees, 0.2. Tangent of 18 degrees, about 1/3, right? So about 0.33 or so. Tangent of 22 degrees is about 0.4. Tangent of 45 degrees is exactly 1, okay? So question, do you have to memorize all those, right? Do you have to memorize those? And why might you have to memorize all those? Because, well, are we, so we're just going to have to memorize the tangent ratios for every acute angle? Is this what Mr. Fortin, this crazy, crazy geometry teacher you have this year, is that what he's going to expect from you think? No. In fact, until I teach these lessons every year, Wednesday and Friday of last week here, I never know what the tangent of 11 degrees is. I can kind of estimate it, but I never know what the tangent of 22 degrees is or the tangent of 18 degrees is here. I know what the tangent of 45 degrees is because that's very clear what it is, right? The rise over run would be 1/1, right? Opposite of adjacent is 1/1. It's an isosceles right triangle. So it's easy for me to remember that. But all the other tangent ratios, remember, every acute angle has a unique tangent ratio. So how many angles are there between 0 and 90, right? If we're talking acute angles here, well, there's actually infinitely many, right? Because you can have 44.2 degrees, 44.7 degrees, 41 degrees, 30 degrees, right? 33 degrees, right? There are tons of angles here. Are you going to have to memorize all of them? Heck no. Heck no, obviously not here. It's because we have tools and we have people who've done some of the work for us to put us in position to start applying some of these ratios when problems in our critical thinking, and when we're going to be tasked for solving things in our trigonometry unit that we're doing right now. So heck no, you don't have to memorize what a freaking 11-degree tangent ratio is, right? The opposite over adjacent, tangent, TOA. People call it TOA, I'll say that later. TOA means tangent is opposite over adjacent. TOA, tangent, I'll get to it all later. Ask your parents. Hey, TOA. My math teacher kept saying TOA when he taught me tangent today. And they'll be like, oh, I get it. Anyways, all of these ratios are stored for us. So you don't have to memorize these here. They're stored for us in a calculator. Okay, we'll get to that a little bit later. And then also in the trig table on page 271. And I might just flip to it right now. Here it is. Look at it. Check it out here. We got tangent. These are all of our tangent ratios that we're going to have to use in problems, solving problems this year. And it's just the whole number values between 1 and 89 degrees. And we'll spend a couple minutes looking at this in the coming slides here. Also in a calculator, just to show you this. Okay, so you might want to have your calculator. Remember these? Right? Remember these? In math class last year? Hopefully you have one of these. If not, you have it on, for instance, maybe your computer, your device here, Chrome, like you just Google Chrome, like you can use this here. You're going to learn a new button, and that's going to be this tangent button right here. Look, tangent button right here. So check it out here. If I do 45 here and I hit tangent, I get 1, right? I get 1 because the tangent of 45 degrees, that opposite over adjacent ratio, is exactly 1. And if I do 22 degrees and I hit tangent, what should I get? Remember from last slide? Tangent of 22 degrees is 0.4. I get 0.404. Wait. Not exactly 0.4. I get 0.4040260. Okay, and if I do, what else here you might have to do here? You might have to do tangent of 18 degrees. I get, I'm expecting about 0.3333 repeating. Oh wait, I got 0.32. So it's approximately 1/3, but not exactly, right? Not exactly here, okay? Because these are just things that have been derived through patterns, right? That math teachers have seen in pretty fancy kind of proving of that the tangent of 22 degrees is very close to this, right? Approximately this, because it keeps on going, right? Here. So anyways, calculators, we'll definitely be using them to get our tangent values, because we're going to use this later in this lesson. You're going to be solving problems using the tangent ratios here. This calculator, right, a Texas Instruments type calculator, is going to have a button there. So just wanted to point that out. You know how to use, now you know how to use yet another button on your calculator. You thought you just you knew how to use like plus, minus, times, divide, but now you can find tangent. So I'll turn my calculator on and I can hit tan. So just practice this real quick if you have it, right? You definitely should come out of this class knowing how to use a calculator and quickly, smartly pull this up. It's going to save you in future classes for sure, future standardized tests, future SATs. I mean, just, geez, yeah, know how to do this, please. Hit the tangent button. I'm going to hit the tangent button. My tangent button's right here. It's usually just above the numbers here in a Texas Instruments calculator. I'm going to hit tangent, and so it says tangent right there, and I can put in any degree measurement I want. So I'm going to put in, well, I haven't looked at 11 degrees yet in a calculator. I'm going to do that. Okay, tangent 11 degrees equals 0.19, right? 0.19. So your book said it was 0.2 when we were doing the lessons on Wednesday and Friday. They said that 11 degrees opposite over adjacent ratio was about 0.2. It's actually like more like 0.194, right? Pretty close to 0.2, pretty close to 1/5, right? But 0.194 is pretty close to 0.2. But anyways, that's how you do it on a calculator. One thing to point out is your calculator needs to be in something called degree mode. Okay, degree mode. You can't see it here, but it says DEG at the very top. I'll put this right up to my my computer here, DEG. That's because the way that your book measures angles is measured in the degree system. Okay, degree system, right? The protractor postulate at the beginning of the book is written for degree measurements. Each angle has a degree measurement between 0 and 180. Okay, when you do some more advanced math, you're going to be measuring angles in different ways, okay? You're going to be measuring angles in something called radians. There are a couple other ways, actually. It's not just one other way you might measure angles, but you might measure angles in something called radians. That actually has to do with the circle, right? How much of a circle would kind of fill up. If you have an obtuse angle, it's like a little bit less than half of one of the circles. But anyways, radians you'll deal with later. We're not going to deal with radians this year. So anyways, if I hit the RAD button right here, radian, I see radian come up here. I don't want that, because if I hit 45 and then I hit tangent, I get an answer that makes no sense, right? I should have gotten 1, right? Tangent of 45 degrees is 1 here. So anyways, here, make sure you are in degree mode, okay? In degree mode for using the tangent function on your calculators here. So now if I do 45, hit tangent, I get 1. Right, and I'm good to go. I'm pulling out my tangent values, okay? So without further ado, the proximate tangent ratios for all whole number angles can be found on page 271. Let's just start looking at a lot of this here. 270, oh man, this is a lot. Okay, so flip open your books, take a look at it, right? You're gonna have to be using this to solve problems, especially if you don't want to use the calculator, but hopefully use calculator to solve these math problems that we got going today and this week and next week. And we'll just do this for a little while. But anyways, table of trigonometric ratios is on page 271. So you see here, the tangent column is this column. Ooh, wait, we see some other words here. Not going to worry about those until a little bit later. Those are some other trigonometric ratios. You can kind of guess, well, there are 3 sides in a triangle. There are 3 trigonometric ratios we're going to learn this year. So tangents over here, tangents also over here, because here we got, I think, angles 1 through 45 are on this side, and then 46 to 89 are on that side here. And here for a 2-degree angle, for instance, the tangent ratio is 0.0349. So that means if I had a 2-degree angle, that the opposite side would be 0.0349 to 1 compared to the adjacent side here. It would be about 3.5% as large as the adjacent side. So it's much, much smaller, right? So we can kind of take this tells us the ratio, right, of opposite to adjacent. Here, right, with a 6-degree angle, the opposite side is about 10% the length of the adjacent side, right? Because the tangent of 6 degrees is approximately 0.1, right? 0.1051, okay? Let's look at this in a little bit more detail here. Let's look at the tangent ratios of the angles we've already investigated. What do you notice? What other patterns do you notice here? So I had this on the slides here just to point out to you that tangent of 11 degrees isn't some clean number, right? These aren't clean numbers we're dealing with today, right? There aren't going to be clean numbers we're dealing with today. So in the reality of things is here, if I actually really had an 11-degree angle, for instance here, okay, let's pretend this is an 11-degree angle and this is actually a right triangle. If I actually had an 11-degree angle here and this were 1, okay, this isn't going to be some clean number. It's not going to be 0.2 for the opposite side here. It's not in a 0.2 to 1 ratio. It's in like a 0.1, right? The reality is 0.194. Math is seldom perfectly clean, right? Unless you're able to get something where it's like isosceles or something like that here, where this is exactly 1. Look, we get the exactly 1 thing down here. So a lot of decimals, right? Rounded out to 4 decimal places to get more precise answers, right? Rather than having 0.2, we were calling the opposite deviation ratio for the 11-degree angle on Friday. It's not 0.2, it's like 1.1. It's a little bit smaller than that. Here. So make sure you're aware of that. Okay. Another very good observation here. So it actually, you take a second, right? Look at this. I know it's kind of overwhelming, just like on Monday, looking at all these numbers, these decimals. What is this here? So maybe you're looking at it. And the thing I want to draw your attention to is this, for a potentially very good observation you might have of this here, is that look at the left side. Look at the right side, right? Look at the left side, look at the right side. Angles 1 to 45, what do you notice for the tangent? Angles 46 to 89, what do you notice about the tangent ratio? What's different? Well, 45 is the 1. We got exactly 1. What happens when it's less than 45 degrees? The reference angle is less than 45 degrees. What can we say? The tangent is less than 1, right? It's between 0 and 1 here, okay? So a very good observation to have looking at this thing, something I always want to point out, to be like, are you pulling up the right information? Are you in degree mode or are you in radian mode, right? Oh man, famous last words. I'm in the wrong freaking mode here. You got to be in degree mode to get this right here. So anyways, to point this out here, the tangent ratios here, look at them. They're all less than 1. Or if they're 45 degrees, it's 1 here, okay? Reason for that is, well, I mean, if you have like a 32-degree angle, for instance, okay? If you have a 32-degree angle, that's pretty acute still, right? That's pretty acute. So 45 is like sort of the threshold of like very acute versus just acute itself, right? Like it's, if you're less than 45 degrees, your opposite side is going to be shorter than your adjacent side of the right triangle here, okay? So if I orient it a little bit differently here, this is one thing I'm gonna have to get used to here. We're used to seeing the reference angle on the left side. I'm gonna draw the reference angle on the right side here. But if I draw approximately a 32-degree angle, okay? So let me just eyeball it right here. Oh, this looks like it's about a third of a 90-degree angle here. So let's say that this is a, 32-degree angle that I'm just sketching in. Okay. The opposite side, right? Remember, this is where opposite is. A lot of times you want to actually sketch this out, like actually write opposite here and then write adjacent down here, okay? Because this is where the right angle is. Opposite here, adjacent. This is where the hypotenuse is here. Hypotenuse is obviously the largest side here, but if I got a 32-degree reference angle, okay, right? Remember, this is where our reference angle is here, I think we're talking about. Okay, reference angle right here. My opposite to adjacent ratio is 0.62. So if the opposite side is 0.6249, the adjacent side has got to equal 1. Okay, be in that kind of ratio here. Okay, so if my adjacent side is length 2, then this is twice that. This is like 1.2. It's about 1.25 or so, right? If I double this. So anyways, anything less than 45 degrees, the opposite side is going to be shorter than the adjacent side here. Your tangent ratio is less than 1, greater than 0, okay? This contrasts this with a slightly larger acute angle that's greater than 45 degrees. Perhaps I will do 58 degrees, which I'm choosing wisely. That's larger than 45 degrees. If I do this, if I have 58 degrees right here, and if you sketch that out, look, this opposite side clearly larger than the adjacent side in the right triangle here. So our opposite side is 1.62, almost exactly 1.6 times as large as our adjacent side. So if this is length 1 right here for the adjacent side, the opposite side would have to be 1.6. If this is a 58-degree angle, we can deduce that here. I point that out too. I chose 58 strategically because, look, remember the acute angles of a right triangle are complementary. 58 would actually be the angle right here. So here, this would be 1 over 0.62, right? So this side is definitely longer than that one if it's 58 degrees. Anyways, don't need to spend too much time on this. We can kind of have this here. All right, let's do this. Let's start thinking about how we'll use these tangent ratios to solve geometry problems. Shall we? Let's do it. Example number 1, let's do it. Oh, check it out. It's out from the textbook. Wow, they gave us this as an example problem. Maybe I'll move it up myself up here. Block the definition for a second, but it says here, example number 1, find the value of z degrees to the nearest degree. Okay, check it out here. What do we have? We have this. This must be our reference angle right here. Okay, how would I do a problem like this? Well, I'm going to be using the tangent ratio here. So I'm going to do tangent of z degrees is going to equal, well, remember, tangent of anything is going to be its opposite over adjacent ratio, okay? Tangent, opposite over adjacent, tangent, opposite over adjacent, tangent, opposite over adjacent, or opposite to adjacent here. So if I'm going to get this as my reference angle for z degrees right here, I'm going to take what's opposite, which is right here, 3, and put it over what is adjacent, which here is 4, okay? So tangent of z degrees would equal 3 over 4, okay? And wait, 3 over 4, hold on a second. That's like a decimal. It's pretty close. I mean, so a lot of your numbers are going to be pretty close to 1, unless your degree measurement's like 89 or 88. Gets kind of higher there, right? You might have seen that on the earlier slides here. So 3/4 is exactly 0.75. So how am I going to get my answer in this situation, right? Wait, my tangent ratio is 0.75. Oh, remember, any acute angle has a unique tangent ratio. So what we can do here is we can take this and right here, okay, look up where it appears on the trig table on page 271. So if I go to 271 here, and I look for tangent, I find tangent, there it is, 0.7536. So it's approximately, right, 0.75, or I'm looking for 0.75 here, and that's 30, that goes with 37 degrees here, okay? So here, z degrees is approximately, z degrees here, again, 0.75, approximately 37 degrees. And we get our answer, okay? Simple as that, right? Our ratio, our slope ratio, our opposite or adjacent ratio, our tangent ratio is unique to that given angle, okay? Another way I could have done this is using my calculator, okay? Using my calculator. This is something called inverse tangent right here. What I can do with my calculator here is, this is a little bit advanced here, but you're welcome to try to use your calculator to do this, is I could take that 3-to-4 ratio, right? 3-to-4 ratio that you have here, 0.75, and then I can do something. I hit my second button here. If I hit second here, I see tangent to the -1 power. Okay, that's something called inverse tangent, right? So I'm not going to write that out, but I'm going to put it here. But where you see tangent to the -1 power, and you see it here, you actually see it on this calculator. You see tangent to the -1 power just above where it says tan here. So if I hit second on my calculator, I hit the second button right here, right? Just the second button here, and then I hit tan for tangent to the -1, and then I put in 0.75, I get 36.86 or so. So I get about 37, which was what I had before. So tangent to -1, there we go. That's a more precise answer than would be in the trig table on page 271. Okay, so you're welcome to do either method that you want to figure out a problem like that. And there we go, written out for you here so that you see it in the lecture slides as well here. What about this problem here? Let's do this problem here. Example number 2, find the value of y to the nearest 10th. Okay, let's do this one real quick. And then I'll take a pause for myself for this lesson here. So I'm going to do tangent of 56 degrees. Okay, tangent of 56 degrees, that's in a particular ratio, isn't it? It's in a particular ratio here, but, right, y to 32 would be in that same ratio. That tangent of 56 is here. So now you're probably asking yourselves, well, this is a little confusing. I have a variable here of y. This is what I'm trying to solve for. So this is our opposite side. Don't forget, choose opposite over adjacent. Okay, opposite over adjacent. So mark them down, right? Make your life easier, right? Here, I go to my opposite here, set that over my adjacent. This here, y to 32 has to be in the same ratio as any 56-degree angle would create for its opposite over adjacent ratio, for its tangent ratio. So this problem here, a little bit different than the last one. What you got to do in this one is you got to figure out what tangent of 56 is here. Okay, this here, tangent of 56, there we have a number for that. We have a number for that. Okay, so what we need to do is use a calculator or page 271 to figure out what this is. Okay, and I'm using a calculator here right now, so maybe I'll do this on this calculator. Simple as this. I'm going to do 56. I'm in degree mode. I'm not in radian mode. And I'm going to hit, get my second off here, I'm going to hit tangent. Oh, wait, ooh, was I in radian mode? Oh, wait, no, that's right. Never mind. 56 is bigger than 45 degrees. Remember, this answer is going to be above 1. Okay, 56, hit tangent, about 1.48. Okay, so I'm going to put this here. I'm going to replace tangent of 56 degrees with 1.4825 or 826 equals y over 32. And now I need to solve for y. So what do I have to do here, okay? Well, remember, this is a ratio, 1.4826 to 1, okay? I could have used my trig table to do that too. So 56 degrees is right here, and look at that, 1.4826, 1.4826. Calculator, page 271. That's what it's going to tell you your tangent ratios. You don't have to memorize them. We have them stored for you here, okay? So this is over 1. So what I could do here is I could cross multiply to get this, right? Yeah, I could cross multiply, or I could just multiply both sides by 32, okay? If I multiply this side by 32 and I multiply this side by 32, I'll have y isolated, okay? Because that's going to cancel out the whole dividing by 32 thing. Okay, 32 times by 1.48. Maybe I'll go to my calculator here to do that. 1.48 times by 32. Brings me to 47, okay, 47.4, okay? So I get 47.4, okay, approximately 47.4. 47.4 is approximately what y's height is, okay? So, right, every angle has a consistent opposite over adjacent ratio. So if this is going to be 1.4826 to 1 here ratio, this is going to be about around 47.4. Helps us solve for y. And here's the answer to the problem as I just did it out before you here. Tangent of 56 degrees, that equals the opposite over adjacent ratio for 56 degrees as a reference angle. So y over 32 is going to be equivalent to whatever tangent of 56 degrees is here. Remember, tangent of 56 degrees is just a ratio itself. There's the ratio right there, 1.4826 opposite to adjacent side over 1, right? 1.4826 over 1. So 56 degrees is bigger than 45 degrees. We know the tangent is larger than 1. And there it is. We got a ratio. Where did we get that? Page 271. You're going to be using page 271. If not, you're using that calculator, right? Using that calculator that, like I showed you previously in the examples here. Okay, cross multiply right here. 1.4826 times 32, and then y times by 1. You don't have to worry about that. We got y by itself. And there we have it, 47.44 for this side here. And just eyeballing it, we can tell that our answer is correct. 47, I would buy that this is about a length of 50 or so, maybe a little bit less than 50. If this is 32, it's about 1.5 times longer here as it is right here. And I can tell that our answer is probably right here. All right, so just reminders here. What was I doing? What do some people really struggle with when we get into this with trigonometry is that, hey, they just struggle when we're solving problems like this and they get something like tangent 56. What do I do? Tan 56 on the last example. Well, you got to get your book open. Got to get your book open. You got to move it over to page 271 because this is going to have all your information to you. So maybe you didn't look at this a little bit earlier in this lesson. I know this is a bit longer of a lesson. They're all long lessons, to be honest here. But you got to get it open. You got to know how to use this. So you find your angle measurement. So say if you're trying to find tangent of 56, you look here. Well, you realize that on the left side here, these are all angles that are up to 45 degrees. Right side here are angles greater than 45 degrees, so 46. So you're looking about here, about 56 or so, and then you're looking to where the tangent is over here. Okay, so see here, tangent of 46 degrees is a little bit over 1. Tangent of 56, a little bit higher than that, right? It was about 1.5 or so, right, that we had on the last slide here. Okay, another thing to do is you could look up tangent of 56 degrees using your calculator in degree mode. So finding tangent of 56 degrees, you have your scientific calculator. Again, you can just use the one on your device, on your Chromebook, but I like using the real calculators here. So clear out your screen, look for tangent. There's your tangent button right here. If I hit tangent and I start with the angle, I want to know the side ratio, hit tangent, and then here hit 56. Make sure you're in degree mode. Okay, not degree mode, not radian mode. You might have to look around for a little bit here. So it's on different places on different calculators. You might have to Google where degree mode versus radian mode appears on your calculator. Okay, hit enter, and I get the same thing here too. I get about 1.48 or so, about 1.5 times the size of the adjacent side, right? Is the opposite side of the 56-degree angle. One more example here, and then we'll wrap up this video. I know, right? I go slowly with these. I don't want to leave anybody in the dust, but that might cause you to zone out, right? And be like, what did we just cover right here? So please, 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 please pay attention to this final example that we have in today's video. And then after that, I'll just film some follow-up videos that perhaps you might want to watch here too before doing your exit ticket, okay? Finds the value of y to the nearest tenth. Let's do this, okay? Well, we get the 56-degree angle again. That's very nice here. And we know that the 56-degree angle has a unique opposite over adjacent ratio, and that's what tangent of 56 represents here, right? This is the opposite over adjacent ratio of a 56-degree angle, and a calculator knows what that is. I just did it right here on this calculator, so what I might do is I might start writing my equation down differently. I'm going to replace this 1.48256, might write that right here, because tangent of 56 degrees, that this ratio here is going to be equivalent to whatever is opposite. And what we have here is 32 over adjacent, and what we have here is y. Remember, this is the opposite side from the 56-degree reference angle. Here, this is the adjacent side because it's the leg that's a part of that 56-degree angle, okay? And then we have our adjacent here. So this is a little bit tougher, right? Tangent of 56 degrees, right? We know what that ratio is. It's about 1.48 or so. 32 to whatever y is has to be in that same ratio. A little bit tougher on this one here because you have y in the denominator. Okay, some students find this a little bit hard to do, but because we've been doing this so much so far this year, this is how I'd recommend you do this when you have a variable in the denominator and not anywhere else, is maybe switch this side to a fraction, right? Make it a fraction, right? The tangent of 56 degrees is that the opposite side is 1.48 times whatever the adjacent side is here. So this ratio would be valid. Then, right, just do what we've been doing all year, cross multiply, right? Cross multiply. 32 times by y. Use the means extremes property. Would equal 32, and y times 1.48, 256 would just be 1.248256 y's, right? That's how many y's we have here. How do you isolate y then at this point in time? Well, this is being multiplied to y, so we need to undo that multiplication. What undoes multiplication? Well, dividing both sides by that particular value. So on this one here, right, we would take 32 and just divide it by the tangent of 56 degrees. Another way we can think about it is that we can do an extreme swap, right? You're allowed to swap your means, and you're allowed to swap your extremes of a particular proportion. But anyways, here, these cancel out. I get y equals, well, I got to do 32 divided by, so I can just try that here. I'm going to do 32 divided by tangent of 56, and that should tell me what my answer is here. So I got 21.58. Hopefully you got the same thing too. I can do that on this calculator too if you want to just see it on Mr. Fortin's computer calculator right here. But I'm going to do 32 divided by 1.4826, and I get about 21.58. Okay, round your answers. I would say maybe round to just one decimal point in the tenth place, I guess. I think that's fine with me here for that now. And let's see if I did it correctly. Did I put the answer on there? Oh, I didn't put the answer on there. All right, one last thing actually before we let you go is that the notation tangent of S, okay, this is tangent of S, that means tangent of angle S. When you see tan x S right here in the textbook, it's talking about tangent of that angle. So it doesn't write the angle notation. Sometimes when we're writing stuff out in math equations, we omit some things that we would say out loud just to make it, we have to write less here. Okay, write less. There's no reason to write tangent angle S, right? Tan angle S. Tan obviously just the first three letters of tangent, so I'm not really going to spend time explaining that, but tan S means the tangent of angle S. Notice how no angle symbol is necessary in this notation, okay? So when you get this in textbook, they're not going to show the angle symbol, but they're talking about angle S here. So a question you might get here is write an equation for the tangent of angle S, and yes, I think Mr. Fortin can do that for you here. Tangent of angle S, okay, and I don't even put the angle symbol, I don't have to. That ratio would equal its opposite, and here the 8 side is opposite. So what I always do when I do problems like this here, and I highly recommend it, sketch it out, right? What's opposite, right? What's adjacent, okay? Remember, this is the hypotenuse right here, so we don't need to worry about the hypotenuse at all. SR is the hypotenuse here. This is the adjacent leg to the side angle, to the angle S. This is the angle S's opposite side here. So we get this. That's an equation, okay? Our answer is done right there. Is done right here. Write an equation with the tangent of angle S. Can we solve for what angle S is? Yes, we can. Reminders on that. How we solve for angle S is we need to do the inverse tangent, okay? Inverse tangent. And what you're looking for on your calculator to do that is you're looking for the button, the tangent to the -1 power button, okay, of 8/3. That's what you're looking. You want to take this. If we have the side lengths, we can get the angle, right? Side lengths, we can get the angle. So if you want to do that on your calculator, right, see here, right above the tangent button, I see tangent to the -1. You hit second, right? Second in order to do that. Anything that's in green, like in my calculator at least, and should be on your calculator, I don't know what color it is, but right above the button, there's a secondary operation that button does. So right above tangent is the inverse tangent. That means if you have the sides, it'll tell you what angle is the reference angle here. Because remember, every reference angle has a unique tangent ratio. So if I hit the second button, I hit tangent to the -1 power of 8/3, it's going to tell me what angle it is here. Remember, I'm in degree mode, not rating mode here. So I got 69.4, okay? So you didn't have to do it in this problem here, but the measure of angle S is approximately 69.4 degrees. And I did everything right? Like that looks like it's about 70 degrees or so. This looks like it's about 20. That kind of makes sense here. So to do that, reminders on this too, 8/3. Well, 8/3 is approximately, what, 2 1/3? 2 2/3. Approximately 2.7 or so, right? So you could also have checked out page 271, right? Page 271 to figure it out here. That's alternatively is, I got 2.7 right at about 70 degrees, right? So I would say, so here, the calculators are more precise because it lets you go to one decimal place. Here, somewhere between 69 and 70 is where 2.66 repeating would be. So that's what the angle S would have to measure, okay? But on a question like this, they're just asking for the equation, right? Just asking for the equation here. So tangent of S equals 8/3. And then you can solve for angle S. You can do that here, okay? And I say this because maybe I'll split this out into different videos. I know this one's getting quite long all of a sudden. So this is sort of your main lesson. Maybe just get out and go. Maybe do your extra ticket now. But in a separate video, what I'm going to do is a little bit of practice, okay? I'll just go through this just so you see examples. We'll do this. We'll do page 267, 68, classroom exercises number 1 through 7 and number 11, so that maybe you give it a shot and you can check out my video afterwards to see how you did here, okay? We'll do all these problems together in the next video. Thank you guys for watching. Tangent, baby. Opposite over adjacent ratio. Hopefully you stayed awake during this video and got what you needed out of this here. Okay, do your exit tickets today. Maybe watch the other videos that I put up here, and no lesson until Wednesday at least. So you just got to do this Monday, Tuesday. Watch it. Email if you have any questions. Have a great Monday and Tuesday. Bye, guys.